What if the next leap in artificial intelligence wasn't about going bigger, but smaller? Think about it. For the last 5 years, every headline screamed about trillion-parameter giants, demanding endless servers and oceans of electricity. But here's the paradox. Google just revealed an AI so compact it can run on your phone, yet so powerful it rivals models hundreds of times larger. This new creation is called Embedding Gemma. At just 308 million parameters, it's smashing assumptions about what tiny AI can achieve. Imagine a model that fits into a couple hundred megabytes, less space than some mobile games, yet still outranks competitors in speed, accuracy, and multilingual understanding. And here's the kicker, it works completely offline. No internet required, no cloud connection. It's fast enough to generate embeddings in under 15 milliseconds, which is practically instant to the human brain. This isn't just another AI announcement. It's the start of a shift from cloud-dependent supermodels to pocket-sized intelligence you control. A future where your device is your AI, and privacy isn't optional, it's built in. But don't take my word for it. Let's break down exactly how Embedding Gemma is rewriting the rules of AI, and why the cloud giants might be sweating right now. Because as impressive as the numbers sound, the real story is how this model performs when it matters most, and we'll get there in a moment. Section 2. The power of small core features and stats. Here's where things get interesting. Everyone expected smaller AI to mean weaker AI, but Google decided to challenge that assumption. Embedding Gemma comes in at 308 million parameters. That's a fraction of the size of LLMs like GPT-4, yet it delivers performance that punches well above its weight. How? A smart architecture split. About 100 million parameters dedicated to the model's reasoning brain, and nearly 200 million devoted to the word lookup tables. This division keeps the model lean without cutting its depth of understanding. With quantization techniques and tight optimization, it runs in under 200 megabytes of RAM. That's light enough for laptops, tablets, and even some smartphones. For perspective, many apps you casually install today take up more memory than that. And then there's speed. On Google's Edge TPU hardware, it can process a 256 token snippet in under 15 milliseconds. That's instant enough that you don't even perceive lag, which matters, because a feature you wait for is a feature you abandon. A feature that feels immediate, that becomes second nature. But here's where it earns real credibility: benchmarks. Across massive multilingual datasets, Embedding Gemma outperforms every competitor under 500 million parameters. It was trained on over 100 languages, which means it doesn't stumble when sentences mix English with Spanish, German, or Arabic. In fact, it thrives in that messy, real-world environment. In short, it's small, it's fast, it's accurate, and it's multilingual. That combination makes it not just impressive, but useful. And usefulness is where AI either lives or dies. But speed and size are just the surface. The secret lies in how the model thinks. And that's where Google quietly pulled off something brilliant. Section 3. The architecture, how it works differently. Most chatbots read text like we do. One word after another, left to right, building meaning step by step. Embedding Gemma, however, doesn't follow that rulebook. Instead, it reads entire sentences at once, using bi-directional attention. Think of it like this. Instead of watching a movie frame by frame, it can take in the entire film at once and understand the story holistically. That's crucial for embeddings, because embeddings aren't about writing responses, they're about capturing the essence of meaning. The model handles up to 2,048 tokens in a single shot, that's several paragraphs, then compresses it all into a single vector, a fixed-length list of numbers that represents meaning itself. By default, this vector is 768 dimensions long. But here's the genius. Thanks to a training trick called matrix representation learning, you can shrink those vectors down to 512, 256, or even 128 dimensions without retraining. That means if you're indexing thousands of documents on a small device, you can cut storage in half or more, and still keep high accuracy. Start big at 768 dimensions while testing, then scale down to 256 for production without sacrificing much. This flexibility makes it both powerful and efficient, a rare combo in the AI world. And before your eyes glaze over with numbers, let's ask something fun. If you could shrink your entire memory into 128 numbers and carry it in your pocket, would you want to? Because that's essentially what this AI is doing. Section 4. Why offline matters. Use cases and privacy. Now here's where this gets personal. Why does it matter that Embedding Gemma runs offline? Because in a world where your every keystroke is logged and uploaded, privacy has become a luxury. This model flips that script. By running entirely on your device, Embedding Gemma lets you search, organize and classify your data without ever touching the cloud. Imagine a personal assistant that can scan your emails, notes or files privately. A small team creating an internal knowledge bot without risking leaks. A phone app that understands your context, even 30,000 feet in the air with no Wi-Fi. And because it shares a tokenizer with Google's Gemma 3N, you can chain them together. Embedding Gemma retrieves the most relevant passages, while Gemma 3N crafts a response, all offline. No data leaks, no tracking, just AI working for you. For many, that's the holy grail: speed, accuracy, and privacy, all in one. And the timing couldn't be more relevant. With growing skepticism about data collection, an offline model gives users back control. But here's the twist: running offline is only half the story. The real shock is how accessible Google has made this model, and that's where things get wild. Section 5. Ecosystem support. Why it's everywhere already. You'd expect a model like this to take months before developers could actually use it. Instead, Google launched it right into the ecosystem. The weights are already live on Hugging Face and Kaggle, and you can run it locally on Vertex AI. With Llama, you install it with a single command. LM Studio lets you test it instantly. Llama CPP compiles it into lightweight binaries for most machines. On Apple devices, it runs seamlessly thanks to MLX and Apple Silicon. For web developers, Transformers.js makes it run directly in the browser. That's how Hugging Face's demo lets you visualize embeddings as interactive 3D maps right on your screen. And if you're a hardcore coder, there's even an Onyx runtime package, letting you drop it into Python, C, or C++ projects without wrestling with compatibility issues. In other words, it's not just theoretical, it's already in your hands. But wait, if it's this good, why hasn't it blown up your feed yet? Well, the answer lies in what happens when you fine-tune it for real-world tasks, and the results might shock you. Section 6. Fine-tuning and training, the hidden advantage. Let's talk training. Embedding Gemma was trained on a staggering 320 billion tokens, web text, code, technical documents, plus carefully generated synthetic examples for edge cases. Importantly, low-quality and sensitive data were filtered out, including strict safeguards against harmful material. To keep leaderboards honest, any model trained on more than 20% of benchmark data is disqualified. Even with that limitation, Embedding Gemma still dominates the multilingual leaderboard under 500 M parameters and posts strong results in English too. But here's the hidden advantage: fine-tuning. Hugging Face tested this by adapting the model for medical data. Using the Myriad dataset, they fine-tuned Gemma on an RTX 3090, nothing exotic. With just 100,000 examples, the process finished in 5.5 hours. The result, accuracy scores jumped from 0.834 to 0.886. In medicine, that's a massive leap. And get this, the tuned version actually outperformed larger, more famous models. The lesson is clear: with a bit of fine-tuning, Embedding Gemma isn't just good, it can be the best tool for your domain. So now we know what it is, how it works and what it can do. But what role does it play in Google's grand AI strategy? That's where the picture comes into focus. Section 7. The bigger picture, where it fits in Google's AI lineup. Google's lineup now has a clear split: Embedding Gemma for privacy, speed, and offline use. Gemini Embedding for maximum scale and quality, running through APIs in the cloud. It's a smart division. Want autonomy, privacy, and portability? Use Gemma. Need enterprise-level muscle at internet scale? Use Gemini. Google has also made the developer experience smoother. The tokenizer is consistent across models. The weights are openly licensed. Documentation includes a full RG Quick Start guide in the Gemma cookbook. And to make the concept click for everyday people, Hugging Face built that interactive demo where you literally watch sentences cluster in 3D space. It's education, visualization, and inspiration rolled into one. Bottom line, this isn't a research toy. It's designed to be used today. And that raises the million-dollar question, does this signal the rise of small private AI, or will the cloud titans still dominate? Section 8, the closing arc. So here's the crossroads we're at. For years the AI story was bigger, bigger, bigger. But Embedding Gemma proves that sometimes, smaller is smarter. Models that fit in your pocket, protect your data, and still deliver lightning-fast results. The implications are huge. Phones that act as full AI assistants offline. Workflows that stay private, even in sensitive industries. Developers fine-tuning models in hours instead of weeks. This isn't just about convenience. It's about control, putting the power of AI back into your hands instead of locking it behind servers you don't own. And that brings us back to the big question, are small offline models like Gemma the future, or will cloud giants continue to dominate? Drop your thoughts in the comments. Do you see yourself trusting a pocket-sized AI more than a cloud giant? I'd love to hear your perspective. If you found this breakdown insightful, make sure to hit that like button and subscribe, because the next wave of AI is coming fast and you don't want to miss it. Thanks for watching, and I'll see you in the next one.